Hi, everyone. Welcome to our session on building a petabyte scale reporting pipeline on GCP. I'm Minhaz Kazi, a developer advocate at Google, and I'll be joined by Michael Wallman. Michael is an infrastructure lead at Google Cloud Platform. In this presentation, we'll be talking about how GCP and Waze collaborated to implement a solution for a petabyte scale reporting platform. We'll also show how this project aligns with the vision for our analytics program. The database management and analytics vision is on the slide, and as you can see, we focus a lot on an open philosophy. We want to deliver flexible features and apply intelligent Google technologies to help our customers. Throughout the presentation, we'll be talking about business requirements and challenges this project had, and then we'll also talk about the technical architectures and data pipelines. Finally, we'll talk about the connector we created and then the dashboard solution we came up with and the outcomes. But first, here's Tommy Hunt from Waze, who will be talking about the business requirements and challenges.
Thank you. My name is Tommy Hunt, and I'm an analyst at Waze. Many of you may be familiar with Waze as a crowdsourced navigation app that helps get you from place to place. We have over 130 million monthly active users across 185 countries that collectively completed over 1 billion navigations in 2019. Our partners and users reported over 60 million traffic incidents each month, and our map is maintained by 30,000 volunteer map editors. Best of all, Waze is completely free for anybody to use. Under the hood, Waze is even bigger than that. We're a mobility platform that helps people move more freely in the communities where they live and work. Just as we give users access to real-time information within the app, we also partner with over 1,300 cities, towns, and nonprofit organizations to share that data through a program we call Waze for Cities, helping to inform their mobility strategies and their responses. In fact, we currently help with more than 60 crises each year, such as hurricanes and earthquakes, and we're helping cities get safer through beacons by giving drivers a way to stay connected even when they're out of range of GPS. In our newest initiative, Waze Carpool is helping to combat the rising congestion in cities around the world. Our city partnerships and community-driven approach is what makes Waze unique and sets us apart from other navigation apps. If you're interested in learning more about Waze, or if you're interested in becoming a Waze for Cities partner, visit waze.com/Waze for Cities. Now, through our Waze for Cities program, we offer a variety of tools and offerings, which include data sharing, carpool, beacons, and crisis mitigation. Today, we're going to focus on how Google Cloud has helped us improve one of these offerings, the data that we share with partners. Through our data sharing offering, Waze provides real-time proprietary incident and slowdown information generated by millions of Waze drivers to inform our partners' mobility strategies. The data we share includes user-generated reports like traffic jams, crashes, constructions, and potholes, just to name a few. Now, before we began working with Google Cloud, Waze data was shared with our city partners via a geo RSS feed in JSON and XML formats. Partners had to take a lot of steps to begin using this data. These steps included ingesting, storing, and then paying for the ongoing storage of this Waze data, among several other technical details. Needless to say, it was really difficult for many of our resource-strapped city partners to consider this process, which really limited most of our partners' ability to use our data at all. So that's why we turned to Google Cloud to find a way to manage and share this data with our partners in a simpler and overall more cost-effective way. Now I'll turn it over to my colleague Michael to talk about the technical implementation of this tool.
Okay, hi. So starting with the Waze and Google Cloud Platform integration. So obviously BigQuery, we started with BigQuery, and in combination with Data Studio was the platform or the services of choice. Okay, challenges. So first, we needed to ingest data from an outside source. So Waze provided us an API to hit, and we use that API to pull in data, all the world's traffic data. Another challenge is that the system had to support thousands of partners at once. So there was no telling when partners were using the system or making queries. So therefore, we had to assume that there'd be a lot of concurrency in the thousands. Simply user-aware dashboards, meaning that if I'm a partner and I go to a dashboard, I would like to see the data that's relevant to me. whereas another partner should see the data that's relevant to them without moving around or having to set that on every login. So that was really important. Another challenge would be if I were to make changes to the default dashboards, they should propagate for all partners. So I didn't want to have to edit or have individual dashboards per partner. It was a requester does not pay model, meaning that partners are not charged for this service, and that Google or Waze in this case is providing the service for free. And then one of the major challenges, which wasn't technical, is that it was a small development team with little to no SRE support. Okay, before I go into details on the technical architecture, I want to call out a teammate, Egan Soares from our LATAM customer engineering team, who really helped design and develop these pipelines. I myself worked with Egan, but also mainly focused on the connector and the dashboard development. So number one, we had our data pipelines. So we ingested the world's traffic data, in essence, into BigQuery. Number two, user management. Partners onboarded to the system through a simple web portal. And then number three, they go to a default dashboard. They get access to the data that's of interest to them. And number four is like how to use the partner's behavior, or how the partners are accessing the data to make judgments on what data is valuable to our partners and what dashboards are they really finding value in, so we can modify the dashboards accordingly. Okay, the data pipeline. We used App Engine Flex and its cron functionality to stream data in from Waze's traffic API into BigQuery partition tables. And so cron would run periodically, and we would basically query the API and pull in all the data for that period since the last run and write it into partition tables. And then from these partition tables, we set up BigQuery scheduled jobs. And so what they would do is they would transform and dedupe the data, writing into cluster tables in BigQuery. Okay, user management. The user management consisted of partners logging into a web portal and selecting the polygons they're interested in. And this gets written into a partner table in BigQuery. We chose to use BigQuery because just for simplicity, it's not, I mean, this is a very small table, so it doesn't really fit the BigQuery use case. But for simplicity, we just decided to keep the user information in BigQuery as well. So following a similar pattern as the data pipelines, we have an App Engine job that that uses cron to run periodically. It looks at the partner table, and based on changes, whether a partner gets added or removed, it creates authorized views for these partners in BigQuery. Now, you see, as you see from the diagram, there's something called intermediate views, and we had to add these because of to work around the 2,500 limit of authorized views per data set. So in essence, we have created views of views, and intermediate views basically use an ASCII regex to doc root partners in different intermediate views, and this allowed us to get over that 2,500 limit. And now Minhaz is going to cover the reporting requirements.
Thank you, Michael. Stemming from the technical challenges we had, we determined what the requirements for the reporting would be. First was that the data for separate cities were in separate data sets. They would have to be accessed from separate data sets. And there we'd have to ensure data privacy because we didn't want any of the partners to see other partners' data. So if they were looking at a dashboard or any kind of reporting solution, they would only be able to see their own city's data and not anyone else's one. There was also the requirement for the centralized billing to have that frictionless user experience, because since we didn't want the city's partners to carry the bill for these dashboard, the billing would be managed centrally by the Waze and GCP team. So there would be a central billing account that would be taking care of the BigQuery querying through the dashboard. There would also have to be a single point of change for all the dashboard edits. That means if a future change was made to the dashboard or if any kind of update was to be made, it would have to get rolled out to all the partners at the same time. So there have to be some kind of a easy deployment system for that. And based on these requirements, we decided to use Data Studio. Data Studio is a data visualization and reporting tool that's available freely from Google Marketing Platform, and it works very well with BigQuery. It has a native connector to BigQuery. If you're using BigQuery data in Data Studio, you can use the BI engine to take advantage of its fast in-memory calculations and get very speedy results. So as the team was looking into this solution, we realized that there were several alternatives available. First was using the native connector to create a single dashboard with viewers' credentials. What viewers' credentials mean is that when someone would view the dashboard, their credentials would get passed through Data Studio into the data source, which here would be BigQuery. And then that credentials would be used to enforce what data they would get to see. And here would be using row-level access, either through Data Studio's email-based filtering or BigQuery's current user function. But the limitation here was that if we wanted to use either of those two features, we'd have to merge all those data sets into one single table or source and then filter from there, which became a little bit complicated because there were over 1,400 partners. The second option was to use, again, the native connector, but there would create one template dashboard and then copy over that dashboard multiple times, like one time for each partner, and then edit the data source so that it would point to the right data set. That had its own challenges because it would be possible to copy over the dashboards, but if we wanted to make any future changes or wanted to do maintenance, doing it over 1,400 different dashboards would become near impossible. So we opted for the third solution, which was the custom connector, and we'll go into that more details later. But what the custom connector would do is it would make a customized solution involving Data Studio and BigQuery. It would meet all the reporting requirements that I just mentioned earlier, and this would require very minimum level of development from the team that was working on it. The custom connectors are built on the community connector platform for Data Studio. These are written in AppScript, which is Google's cloud-based serverless scripting engine, and it takes a very low amount of effort to build connectors using this framework. Anyone can build a connector. You can connect to any external data sources and pull in the data into Data Studio. And it's also possible to share and publish those connectors so that others can use. If you are interested in learning more about these connectors, you can check out the code lab we have at this URL on the screen. The community connectors is already an established program where there are over 200 published connectors available. And here at Google, we ourselves have used this platform to create several connectors to serve data to the public. For example, the Chrome UX connector uses this connector platform to serve Chrome UX report data to users. So it was already a proven solution for us. However, one thing we have never tried with these solutions was that we didn't implement the user-based view in any of these connectors. So what that means is in user-based view, multiple users will look at the same dashboard, but based on their credentials, who they are, it would fetch data from different data sets, which is a bit different from row-level access because we're accessing completely different data sets, and then the dashboard would get populated with data from those data sets. So this was something new that the team was trying out with the community connector approach. And our end result would look something similar to this, that the connector would get created, and using that connector, we'd create a dashboard, a single dashboard link, and that would be sent to all the 1,400 different partners. When a partner opens their dashboard link, they will see their dashboard with their own data, and they wouldn't have any flexibility or option to switch over to see a separate user's dashboard. So this is the complete user experience we wanted to have. User gets a link, clicks on it, they immediately view their report. So to do this, under the hood, this is what we had to implement. So once the user clicks on the dashboard link, it opens up the Data Studio dashboard. And the Data Studio will then execute the connector with viewers' credentials. The first time any user opens this dashboard, they will have to go through an authorization flow where they authorize this connector to run on their behalf. But this is done only for the first time they use it. For all subsequent times, the dashboard will open up automatically. So Data Studio executes the connector script, and the connector script then takes the user credentials and figures out, all right, this is the email for this user who's viewing the dashboard. And then it makes a call to the BigQuery REST API to figure out which data set should this user be viewing. So we had a mapping table that mapped each user's email address with a specific list of data sets. So this REST API call enabled us to query into BigQuery and get the result back where BigQuery would say, all right, this email address X has access to dataset Y. So once this information was back in the connector, we'd then construct a new query. And this query string would contain basically this data set ID that we just fetched. So it would say something like select asterisk from dataset Y. But we would not send this query off to BigQuery directly. What we would do is that then the connector would use the BigQuery, the Data Studio Advanced Services to make the query directly into BigQuery. So let's look a bit deeper into that, what that means. To communicate between Data Studio and BigQuery, the native connector directly works. But when we're working with a community connector, the data will usually have to pass through AppScript, and it will have to be transformed and processed in AppScript, which adds a bit of overhead in calculation and latency. Using advanced services for Data Studio, what we can do is, rather than passing the data through AppScript, we can just pass the query itself to Data Studio, and the Data Studio will pass that query to BigQuery directly and fetch the data from BigQuery using a native connection. The data does not pass through AppScript in any way, so it results in a much faster interaction. All the filters are automatically pushed down, and then the users also get a much better, faster dashboard experience. So finally, Data Studio passes that query into BigQuery, which is the final query for the dashboard, which contains only the data set that this user has access to see. And finally, the results are sent back to Data Studio, and Data Studio renders that data in dashboard, and the viewer finally can see their dashboard with their own data. So since in the return query results step, only the user's data set is passed, there is no way for a different user to see that data set, or for this user to see data from a different data set. So what does the end result look like? This is the whole process, but when the user finally opens the dashboard, they get a view that looks something like this. This is the view that all the users, all the 1,400 different partners see. When they open the dashboard, they get a dashboard like this. At the top, there are filters. They can change the filters. They can interact with it. And this dashboard will interactively present the data for whatever filters or selections they're making. Each partner would see only their view and they won't see anything else. And based on this dashboard, the team made some further improvements where they added further pages. They also added some monitoring where they could monitor how the dashboard was being used through Stackdriver, which partners were using it, which partners were incurring additional data costs. It's also possible to set up data limits by partner. So it's a future potential work is where we could potentially take this solution and then built in limits where each partner would get, say, a certain amount of limit. If they hit that limit every month, then their dashboard won't become visible. Another potential solution that can be implemented on top of this is using Google Analytics for Data Studio. It can be measured how the users are interacting with the dashboard. Which pages are they looking at? Which pages are they spending the most time on? And then make the dashboard much better and faster and more usable for users that way. If anyone wants to build a similar solution using Data Studio Advanced Services and BigQuery, these links would be helpful. The first link basically provides a step-by-step guide on how to build a connector similar to this. And the second link contains a code example of a similar connector. You can just take the code example and customize it to your own needs. So what finally happened after this project? This project was launched in October 2019. After launch, there were numerous positive news stories. Over 200 news stories were published on digital trends and venture beats. Right now, over 6,000 users from more than 1,400 partners across the world are using this dashboard every day. And as Michael mentioned earlier, the connector that he created and the dashboard the team came up with, it's working basically in a no-ops fashion, even with such high amount of usage. And there are over 30,000 accesses of the Data Studio dashboard, and more than 800,000 queries have been made in BigQuery by all these partners. Now, Waze This was a major collaboration between Waze and Google Cloud, and Waze plans to continue to promote the data tools and build education materials to aid traffic planning across the world. And that brings us to the end of our presentation. Thank you.